Hello and welcome to the Engerati studio here at European Utility Week. I'm joined now by Julien from C3 Energy. And Julien, first of all, welcome. Thank you for making the time.
Thank you very much.
And at Engerati, we've been talking to C3 for quite some time, probably over the last 2 years of the existence of the network, and you've spent a lot of time telling us about the use of analytics and so on. But things change. The conversations start becoming more real. They move from a conceptual to a real world environment. And what I'd like you to do, if you can, is tell us a little bit about what you're doing with Enel and how you're working with that utility. Bring some of that to life for us.
Right. No, and I think your point is very valid, which is there's been a lot of discussions around analytics and what that means to the utility industry. But in the end, we're just starting now to see full deployments at scale of analytics and what they can mean. So today and in other conferences, a lot of people will talk about it, but there are not that many real full deployments out there. And I think the example of what Enel is doing right now and how they use C3 Energy technologies is extremely interesting for us as a whole. And so we've been collaborating with Enel for the last couple of years now, and we started with a number of pilots, and then those turned into full production systems, and those have been in use now for quite a while. And so with Enel, we've been focused on a couple of major areas right now. One is revenue protection, so how do you address non-technical losses? And we've been applying those technologies both in Spain and in Italy. And the other big area we're tackling is predictive maintenance. So another area which is extremely interesting to the industry, and how do we use all of the sensor data and all of the operational systems data in order to predict failures. And those can be predicted on a distribution network, on the generation equipment, on the renewable generation equipment, on a number of different assets, and those provide enormous amount of value.
And with that, actually, let's dive into both of those use cases for a second. So with the revenue protection piece, what is this new analytics bringing to bear, and what does the ecosystem need to look like? Because a lot of people often talk about smart meters.
Right.
You need a smart meter, you need but equally, when we look at this space, there are people who are saying, well, you may not necessarily need a smart meter because you can do analytics over the voltage lines, you can see fluctuations, you can use big data to predict stuff, and you may not need the meter. So I don't want this to be a conversation about do you need the meter or don't you need the meter. But
that would be a long conversation.
Exactly. But what how are you creating those models or algorithms to do the revenues protection side of things?
Yeah. So you asked about Endesa. I think it's a very good example. Because Endesa, as you know, is the #1 electricity operator in Spain. They have about 10,000 employees. They have 31 billion in revenue. So it's a huge utility. Now they have three main categories of meters. They have the smart meters, they have monthly meters, and they have bi-monthly meters. Okay, so that's the three large categories of meters that they have, and they've deployed revenue protection on all three. The way we went at it is creating a unique platform for all three meter types, but there are different classifiers, different machine learning algorithms, and we can talk about that for each three of the different meter types. And it's true that we get much better results on the smart meters, and all of the sensors and all of the data makes it very fine predictions, but we can get very good results as well on the non-smart meters. What we see so far with the deployment at Endesa is that we have tripled their identification rates of non-technical loss cases. That generates obviously an enormous amount of value for Endesa, which we estimate to be somewhere around 75 million euros a year.
So just that alone is 75 million euros of
annual recurring benefit
benefit to Endesa. And then the other piece, and let's talk about that as well, because what I want to bring out of this narrative is that it's not just one thing. The predictive maintenance side of things. Is that something that is only able to be done now? And the question I'm trying to get to is, what does the platform need to look like? What do you need to do anything, if anything at all, to the distribution network in order to apply some of these predictive algorithms over the top of it?
Yeah, I think it's a great question. Obviously the networks, but the entire energy value chain as a whole, from drilling to exploration to generation transmission, everything is becoming censored, right? And that's the trillion investments that are going on in this decade on the grid in particular. And this is generating an enormous amount of data and information for us to analyze. And those sensors, if you don't take the data and if you don't analyze it, they're not that helpful. So the censoring of the network, whether it's a seismic sensor, whether it's a pressure sensor on a transformer, or whether it's a smart meter, this generates the information, and we can then use this information in order to make better predictions. The point is, at which point how much data do you actually need to make a good prediction? And that will depend greatly. The more data, the better the prediction, but also the more localized your prediction will be. Right? So if you have a sensor on a substation, for example, and you use that, or if you have it at various areas of your grid, the more fine your precisions will be. But I think what makes it unique is the ability to collect, and at least that's how it works at C3 Energy, the ability to connect all of the sensor information and combine it with all of the operational systems that you currently have. So your outage management system, the weather information, the workflow management system, the mobile workforce management systems. So it's really combining both the sensor data and the operational system data that creates the value for the utility. And if you only have one, or if you only have the other, you create a point-to-point solution and you are not going to get the same amount of value.
So how do you tackle some of the other things that we hear out of the utility sector, the things that utilities themselves say, where they feel they've got data quality issues, they've got data silo issues? Is this approach actually helping to solve any of those, or do you need to fix those differently?
That's a great question. I'll tackle the data silos issues first. The data silos exist in the utility industry more than anywhere else, I think, for a number of reasons. One, the grid has been verticalized, right? It's been shut down. So already you have silos based on meters, customer, distribution, transmission, generation. And then even under those verticals, right, you have a huge amount of different systems in there. You'll have the billing system, you'll have the ERP, you'll have the workforce management systems, meter data management system. All of those systems have been created by different vendors at different points in time, different technologies integrated by different system integrators. So that has created a system of silos. Where we come in is we provide an over the top layer where you can connect to all of those systems, extract the information, federate it into our cloud image, and then end up having your information in one area. And
so it's an abstraction of the existing system.
It's an abstraction of the existing systems, and we take all of those information from those existing systems, but combine it with the new data from the sensors, whether it's a smart meter or another type of sensor, and load it in a federated cloud image. And the way we can make this successful is through extreme performance and leveraging cloud technologies in particular, and great programming. We can load up to 1 million transactions a minute right now.
And so when you have that, isn't there a case whereby and everything you said to me sounds quite nice and would look quite nice on a PowerPoint graph and everything, but when someone hears this, I always feel that what they hear is complexity, pain, data integration issues, and all that sort of stuff. What are some of the barriers that you see out there? And you talk about it quite eloquently, and we can hook all this up, but surely it's not as simple as that.
I think the big difficulty now is extracting the data from the current existing systems. Some of those are pretty old. Some of them are still written in very old technology. So extracting
probably still run on DOS, right, or something like that.
Or you see a nice green screen somewhere.
Yeah.
And so extracting the data from those systems can sometimes be the challenge. You don't have necessarily the people that were there when it was created. But once the data is extracted, through the technologies we've created, you can abstract it and you can load it and you can transform it into what we call our data canonical format, which is a standard format that you can load information into. And then you can load it into our federated unified cloud image. And once it's in that cloud image, that's where you can apply the analytics. And to go back, with Enel, we created more than 750 algorithms for predictive maintenance of a distribution network. At Endesa, we've used the same information and we've used more than 250 analytics for revenue protection purposes. So getting the data in one place is only the first aspect of the challenge. The challenge is in the extraction rather than in the importing. Once it's in that image, whether you do it batch or streaming, you apply your analytics and then you apply machine learning techniques to it to identify and validate the cases.
So in a way, what you're also saying, and I'm going to put this very simplistically just to put the point across, is the more distribution networks that are running on this, the more sort of analytical algorithms you can run on distribution networks, because at the end of the day, the unique thing is we're dealing with the laws of science on the distribution.
Exactly.
You know, the electron is no different in India than it is in
some might argue differently,
Germany, but
physics is the same everywhere.
Physics is the same same everywhere. So surely the other thing that will happen is, and are you able to do this, that if you see an algorithm working particularly well on one distribution network, you can say, oh look, we've got that now. We're going to apply it to another one and another one and another one, and through that scale you get better and better and better. Is that how you're doing it?
Yes, absolutely. Yeah. I think this is a great point. I mean, this is an industry which is still in its infancy. We're still at the beginning of this, and already as of today we can get enormous amount of value. I mean, you asked about the meters. We think right now through analytics you can get about 300 euros or dollars depending of value per meter for both the end customer and for the utility as a whole. But you're right. Right now, those algorithms, those machine learning techniques, they're pretty new and they get better all the time. And our objective is to leverage those algorithms as much as we can on various systems and networks, and continue to help improve the efficiency and reliability of the grids everywhere.
So you mentioned meters, and we've talked a lot about sensors and things like that. You know, I get a sense that there's a conversation that is moving the smart meter conversation to a different domain, where I kind of felt, and maybe this is a UK-centric view because I believe they've kind of made a hash of explaining smart meters to the public there, but that's my view, not yours. It's all been about billing, accuracy, revenue, and some of the theft protection side of things. Sure. But do you not think that where we're getting to now is the distribution networks are realizing that actually if you move beyond that mentality, you turn the data up, that these meters are providing actually edge intelligence and become a fabric of the maintenance of the distribution grid rather than just some billing mechanism?
No, I totally agree with you. And even though the business cases for smart metering very early on were on providing real-time access to customers on their consumption data, somewhat the ability to provide real-time pricing signals, remote shut-off and remote disconnect and reconnect, I totally agree with you. Now the utilities are starting to see that you can get a lot more value from those meters as devices on the network in the same way as the other devices that help you operate a much more efficient network, especially now with a lot of the distributed generation, right? That's the other enormous transformation, which is you used to have a few big generators and you would just ship the power there. Now the generators are all over the place. The smart meters are great devices to help you control this input of new energy into your grid and into your operation. So I totally agree with your assessment. Utilities right now are seeing a lot more value from those smart meters than what they might have seen at the beginning of their use cases.
So tell me, with those, you mentioned the figure up to $300 of value out of a meter or a sensor. We've got other people saying, oh, you can get about $10 of return for every smart meter per month across your network, so there's like huge variance between all these numbers. Do you think that variance is actually down to the sophistication of the use case, that actually the more sophisticated we get, the more value we can put on it, and those early numbers were unrepresentative because they were unsophisticated use cases? It was just, like you said, billing, and
yeah, I think your analysis is, I share your analysis. I also think that in order to make those assessments, we spent a lot of time to calculate the value behind our systems and to identify use cases where data and sensor and combining sensor and operational system data would make sense. But in the end, those business cases and the value assessment is not that complicated. We've talked a lot about non-technical loss today, right? But let's say you can identify half of your non-technical loss through analytics, which is a pretty safe assumption, and right now we're much higher in most of our implementations. Let's say the utility, through their business process, can recuperate 50% of what they identified. Assume a generation cost of electricity of around a cent. That provides you with a economic benefit of $10 a year. So it's a simple calculation which makes a lot of sense. You combine that with all of the use cases that you can have, and it's about $300 per meter per year.
And then as we're coming to the end of our time, just to wrap up, we kind of spent some time on the technical loss side and revisiting the use case and so on. How big a benefit? I mean, I don't know which particular use case we should draw on, whether it's the Endesa or the Enel use case for this one.
Sure.
But how big of a benefit is this sort of predictive maintenance side of things? Because I would imagine it must be pretty powerful to tell someone, and again, I'm simplifying the analogy, a substation is going to blow up before it blows up.
Right.
And how accurate can you get with that?
Yep. So it's a great point. Well, I mean, with predictive maintenance on the grid, you can do a lot of interesting things. Yes, you can predict which transformer is going to blow up, but you can also predict what the impact of that transformer blowing up will be, right? I mean, some transformers are critical, some others might not be as critical, right? So you can also prioritize your workforce this way. You can do it on transformers, you can do it on wind turbines. If a gearbox fails in a wind turbine, it's very expensive to take the turbine down and repair it. Whereas if you know that you have a problem, you might get someone up there and fix it on the spot, right? So there's a lot of value there. So there's a lot of different things you can do. One of the key challenges is moving your planned maintenance and your scheduled maintenance into a more predictive approach that helps you save money. And the second is in terms of capital investment, which assets should be replaced in what time frame, rather than a manufacturer saying after 15 years you should replace that asset. It might still be perfectly fine and operate for another 5 years, and you might get a lot more life out of that asset. So I think predictive maintenance is going to generate an enormous amount of value for this industry. The results we get at Enel are phenomenal. On one grid area of 1,000 feeders, in Italy, we got 40% precision in terms of the predictions we made, which is phenomenal in terms of providing value and rerouting resources where it matters most for the end consumer. And we as consumers, we win, right? It limits our outages.
Yeah. And did they do any calculations about having that 40% accuracy? How, if at all, that affected the bottom line and things like that? Because at the end of the day, every business case at some point has to end up at the bottom line, right?
Yes, and it does help the bottom line dramatically.
Yeah. No numbers you can share.
No numbers
with us
today.
Okay. Well, we'll work on getting numbers out of you guys later on. And just to finish off, just to wrap, I just wanted to ask one thing about where. And this is just a thing. Very early in the conversations we were having with CT Energy, there was still that distrust of moving into a cloud environment.
Yeah.
Are we done with that?
I think we're way past this now.
Good.
Yeah, I think the cloud issue is not an issue anymore.
Yeah.
I think people value now the cloud and the security it provides. And I was talking to a CIO the other day who said, sorry, we're not talking about analytics right now because I have water leakage in my in my data center, right? So if you have that issue that's preventing you from moving forward, you might as well use the cloud and benefit from that.
Stick it all up there. Well, I'm glad that conversation has moved on. Julien, thank you very much for joining us.
Thank you very much,
thank you as well for watching this Engerati interview, and there are many more on our website, as you probably know by now, and many more to come. We're live here from European Utility Week in Vienna for a change, so I've had to learn that. Thank you very much.
Ryan. I appreciate it.